Hello students, today we discuss the concept of intervals. All of you learned this concept in your previous years, open interval, close interval. So today we learn definitions of intervals. Okay, so let us start our concept intervals. First point is let AB belongs to R with A is less than B. That means A and B both are real numbers and without loss of generality A is less than B. Okay, the subset of R denoted by, this is called as open interval AB, open braces A comma B, and it is defined as AB is equal to the set which contains the element X which are real numbers, that means X belongs to R, such that A is less than X is less than B. That means the set AB contains all the elements between A and B, the elements between A and B. For example, suppose we consider the set 2 5, open interval 2 5, then open interval 2 5 contains the elements between 2 and 5 which are greater than X and less than B. That means the elements which are greater than 2 and less than 5. So greater than 2 is 3 and 4 and 4 is less than 5. That means the open interval 2 5 contains these two elements 3 and 4. Okay, so open interval contains the elements which are lies between their limits, lies between their limit, starting limit and ending limit. Okay, this is called as open interval. Now second point, the subset of R denoted by close at A and open at B, close at A and open at B, it is defined as, it is the set X belongs to R which contains the element A is less than or equal to X is less than B. That means which contains the element X which are less than or equal to A but which are strictly less than B. Okay, so here we see example for this closed interval. Suppose we consider this example 2 5, open at close 2 and close at 5. So this set contains the elements which are less than or equal to X. X is less, that is 2 is included in that set, that means 2 3 and 4. So this set contains the elements only 2 3 and 4 since it is closed at 5. So all the elements which are less than 5 and which are less than greater than or equal to 2. So this set contains 2 3 4. So now third point is the subset of R denoted by open at A and close at B, open at A and close at B, it is defined as the set which contains the element X belongs to R such that A is less than S is less than or equal to B. Okay, so this set contains, same example we consider here, the same example, open at 2 and close at 5. Now this set contains the element which are strictly greater than X, A X which are greater than X, that means greater than 2, greater than 2 is 3 4 and that X is less than or equal to B, it is equal to B, less than or equal to B. That means this set contains the element 3 4 and 5. ओके, म्हणजे ज्या साईडला क्लोज आहे त्या साईडला आपण त्या साईडची इलेमेंट्स आपण त्या सेटमध्ये ॲड करणार आहे विच आर ओपन ॲट ए अँड क्लोज ॲट बी. ओके, नाऊ लास्ट इंटरवल इज क्लोज इंटरवल ए बी, बोथ साइडेडला क्लोज ब्रॅकेट्स आहेत त्याला म्हणायचं क्लोज इंटरवल. क्लोज इंटरवल ए बी विच कंटेन्स द ऑल इलेमेंट्स ए लेस दॅन ऑर इक्वल टू एक्स लेस दॅन ऑर इक्वल टू बी. दॅट मीन्स अगेन वी कन्सिडर सेम सेट close at 2 5. Now close at 2 5, the set which contains the elements or these elements x x which are greater than or equal to 2. So 2 3 4 and less than or equal to b. So here A and B both are included in the set, A and B both are included in the set. Okay, so this is called as close interval. Okay, now here AB both side ला open bracket आहे ते open interval, both side ला close bracket close interval. Okay, here one side is, that is left hand side is close and right hand side is open, then it is semi open interval. And if left hand side is or right hand side is closed, then it is called as semi closed interval. Okay, this is very simple concept. Now here consider one other set, open interval a infinity. Open interval a infinity is the set which contains all the elements x belongs to R which are x greater than a. All the elements are greater than a. So it's greater than a. Suppose the set contains 2 infinity. If 2 infinity is the set which contains the all elements which are greater than 2. Greater than 2 means 3, 4, 5, 6 and so on up to infinity. Okay. These all elements are included in this set a infinity. Open interval a infinity. Now close interval a infinity, all the elements x belongs to R which are greater than or equal to a. Greater than or equal to a. That means to infinity. To infinity. That means here which contains the element, all the elements which are greater than or equal to 2. So here 2 is included in the set. 2, 3, 4, 5, 6 and so on up to infinity. Okay, minus infinity to a, open interval minus infinity to a. So all the elements x which are less than a पेक्षा less असणारे elements all such, or that is all negative elements which are less than a, and minus infinity close at a, again all the elements which are less than or equal to a, that means a is included in that set. If the set is closed, then their limits, upper limit and lower limit, are included in that set, and if it is open, then the elements between upper limit and lower limit are included in the set. Okay, now one more concept here, neighborhood. Now what is neighborhood? Let a belongs to R and let epsilon greater than 0. This term is called as epsilon. Okay, this is very small number. Epsilon, it is a very small positive number. So let epsilon greater than 0 be any positive real number. Then epsilon neighborhood of a, it is denoted by म्हणजे n a epsilon. N it is sign for neighborhood, a is center and epsilon is its radius. That means as a small, here a is the point on the real line, here a, and epsilon neighborhood. So epsilon is very number, epsilon neighborhood of a, n a epsilon, and it is defined as n a epsilon is equal to x belongs to R such that modulus of x minus a is less than epsilon. ओके, म्हणजे त्याचं एप्सिलॉन नेबरहूड म्हणजे ए इज सेंटर अँड एप्सिलॉन एवढी रेडियस घेऊन जर सर्कल घेतलं तर या सर्कलच्या इंटेरियर पार्टमधले सगळे इलेमेंट्स विच आर लाईज इन द नेबरहूड ऑफ दॅट ए. मॉड्युलस ऑफ एक्स मायनस ए इज लेस दॅन एप्सिलॉन. ओके, नाउ हियर वन एक्झाम्पल ऑन दिस. हियर व्हॅल्यू ऑफ ए इज -1, व्हॅल्यू ऑफ बी इज 1. फाइंड n a1. We have to find the value of n a1. Okay, that means a is center and here value of n a epsilon. So here value of epsilon is 1. So n a epsilon, that means a is, here value of a is -1 and value of epsilon is 1. Okay, so how it can be calculated? So n a1 is equal to what? a minus epsilon a plus epsilon. हा कॅल्क्युलेट कसा केला जातो? ए मायनस एप्सिलॉन ए प्लस एप्सिलॉन. ए इज द सेंटर. ए हा पॉईंट इन रिअल लाईनच्या सेंटरवर असणार. सो याच्या मागचे पॉईंट्स आणि याच्या पुढचे पॉईंट्स एप्सिलॉन, याच्या एप्सिलॉनच्या ए प्लस एप्सिलॉन, हियर ए मायनस एप्सिलॉन. ओके, सो ए मायनस एप्सिलॉन, दॅट मीन्स -1 ए प्लस एप्सिलॉन -1 + 1, that is -2 0. So n a1, neighborhood of a1 is equal to -2 0. So it is quite simple to find neighborhood of any number. Okay.